Let's jump into this guideline and see what it's all about. So the first question was, in addition to incinerators, what are examples of types of facilities using alternative fuel, underlined, which it also applies to? And the answer to this question is cement and lime kilns. So we've talked about municipal solid waste going to dedicated facilities that are only intended to treat the waste and do some energy recovery, but it's very common for industries that use a lot of heat for their processes, namely cement and lime kilns, also to use solid waste as an alternative fuel. And then that heat will actually be used directly in their process rather than being used to heat steam and then generate electricity. So cement and lime kilns have to follow similar requirements as waste incinerators when they're using waste as a fuel. So they look different kind of upstream, but on the air pollution control side, they will look very similar to what we'd require from a solid waste incinerator. Number two, does the guideline apply to pyrolysis and gasification? The answer is yes, if they combust anything and produce a flue gas, otherwise no. So as I mentioned in the previous video, with pyrolysis and gasification, we can export all those gases, liquids, and solids that we produce and do something else with them, create fuels or create new materials, or we can burn them. And if we burn them, then it'll be basically the net reaction is an incinerator. So it would also fall under this guideline in order to treat the flue gases. Number three, of the emission limits, which compound has the highest allowable emissions and which compound has the lowest? And the answer, the highest threshold is nitrous oxides, and the lowest is dioxins and furans. So what that means is of the whole list of contaminants in there, nitrous oxides are the least hazardous because we're allowing the most out, and dioxins and furans are the most hazardous. And I'm going to talk about what dioxins and furans are in a moment, but they're as you can see from where they stand on the list, one of the most toxic things that it's present in municipal solid waste emissions. Number four, in addition to the ECA for the site, thermal treatment facilities must also comply with OREG 41905, which is also made under the Environmental Protection Act. What is OREG 41905? 41905 is the local air quality regulation, and that sets permissible emissions and ambient air quality criteria. So this is similar to what we talked about with odor treatment. We also don't want other pollutants going off our site in certain concentrations, and that's what this regulation covers. Number five, what parameters are considered for continuous monitoring? These are temperature, organic matter, carbon monoxide, oxygen flow rate, hydrochloric acid production, sulfur dioxide production, nitrogen oxides, opacity, particulate matter, carbon dioxide, hydrofluoric acid, mercury, dioxins, and furans. So there's a whole suite of things that you need to be constantly monitoring in the flue gas from these facilities to be able to tell if both the facility is operating correctly and if the air pollution control equipment of that facility is also operating correctly. So there's a lot of things to keep track of, and that's part of the expense of these air pollution control systems. Number six, which factors can create incomplete combustion products as discussed in the regulation? So these include low temperature and incomplete oxygen, and we're going to talk about this a little bit more. There's kind of a hierarchy of pollution where we prevent things first by trying to preclude some of these conditions where pollutants form. And then the next step is to remove them with the air pollution control system when they do occur. And the last question, what measures are required to avoid fugitive emissions? So these are emissions that are not coming up our stack where we want them, they're coming out elsewhere. And similar to organic waste facilities, the practice is to operate the buildings under negative pressure. So anything that is escaping into the building is going to want to stay inside the building. There's going to be a net movement of air into the building rather than out of the building. And then you'll frequently use air collected from inside a building in a waste receiving area as air for the aeration of the incinerator itself. So you reuse that air, and then anything that has been pulled in from the tip floor will be either destroyed in the incineration reaction itself or will be caught by the same air pollution control equipment with the rest of the flue gas. So there's quite a bit in that guideline. But some of the things it will have raised are, for example, the key pollutants that we are worried about in flue gas from thermal treatment operations. And the big 5 groups that we're looking at are dioxins and furans, acid gases, nitrogen oxides, metals, and particulate matter. So dioxins and furans, as we saw in the guideline, are a class of very toxic organic molecules. Over on the right of the screen is a picture of one type of dioxin. And dioxins are most famous in recent years for being used to poison the former president of Ukraine, Viktor Yushchenko. And you can look at kind of what he looked like before and after the poisoning and get a good sense of what these chemicals can do to someone's body. So that's a really acute case. He was targeted for assassination with these chemicals, but even if they're used in lower concentrations, they have very serious effects on human health and the environment. So they're something of key concern. They have the lowest threshold in the Ontario Guideline, as we saw. Next, we have acid gases. So these include acids of fluorine, chlorine, and sulfates. And these form acid rain. That's their main environmental effect. So we don't want to be putting them into the environment. Then we have nitrogen oxides. Again, these can contribute to acids, and they can also contribute to photochemical smog. So we don't want to be putting too much nitrogen oxides out. Then we have metals. So a lot of metals will end up in our bottom ash, and we'll actually be able to recover them from that. But other metals, notably mercury, will vaporize, and then they'll end up in the flue gas. And mercury, we also know, is a pretty serious toxin that we don't want getting out into the environment. So that's something of key importance. And then the last one is particulates. So particulates just means solids, right? And these are actually a huge problem globally for air quality. Even just cooking over a fire, you'll have really hazardous effects to your health from breathing in those particulates. So when you combine that with maybe these particulates are absorbing some dioxins and furans or mercury, they're even more potentially hazardous when they're coming from solid waste incinerators. So that's our 5th class that we're going to pay attention to as we're looking at our air pollution control technologies.